dojo, dark mage in the house with the sick flow. Listening to Evil Dojo, Dark Mage, in the house with the sick flow. Listening to Evil Dojo, Dark Mage in the house with the sick flow.
Hey everybody, I thought I would have a little bit more time to get started here, but my dog is awoken from her nap, so we're gonna go do a little bathroom break. And when I get back, I'm gonna kind of coax her, chill her out a bit, and we're gonna talk about the Redking Hivemind. And if you're interested in doing some Python, if you're interested in doing some networking, some encryption, some asynchronous communication, then you've come to the right place. But first, I have to go take care of this, so I'll be right back. Enjoy some music in the meantime. Okay, we're back. I'll probably end up reaching over, talk to my dog during this cast, but got my chat open. If anyone has any questions or wants to chat during the stream, by all means, please interact. All about it. But time is of the essence. So pretty much all the code that's up here is currently synced with the repo. So check it out up there. Let's get started here. The code's starting to get kind of bloated, and any opportunities I can take to clean things up, I'd like to. But on top of that, we have some new extensions since the last major stream when I got the Sandberg swap working. One of the big upgrades is that there is now encrypted communication. So by this, I mean, check it out. There's our bot master. There's our bot main. And we have some new features. We can now ping not only the bot master, but we can also have the bot master ping a now that one's a little bit interesting because it actually returned it actually returned an AES encrypted ping. So it would be curious if we want the bot master to actually respond to ping in that way, but as you can see, it returned a encrypted ping or pong back rather. So in order to decrypt this pong, you would actually have to have the AES key on hand, because what I've implemented in that regard. So here's raw ping, right? Raw ping super easy. It's like, in fact, let me drop the text a little bit. There we go. So like asynchronous communication in Python is actually pretty straightforward once you have the setup right. You receive a reader and a writer after opening a connection. You don't have to close the reader, but you do have to close the writer, and closing the writer closes the reader at the same time. And then you have to basically drain the writer with an await. You close the writer without an await, and then you wait close with await. And that's the pattern basically. So understanding this back and forth communication style, you can implement a very simple ping. And so in this case, we're actually this given a port sorry, a host and port, we can actually command the bot master to actually send a ping without it being encrypted. And you want to do this in the beginning because the bot isn't instantiated with an AES key yet. And I'm trying to resolve this race condition where, let's say you spin up like your bot master, right? Like there's a time in between spinning up a bot and it actually getting attached to the network, because one, we have to verify that the bot is actually up and running, and maybe we don't even have to do that. Maybe we could just make the assumption that it's up and running by like attempting to hard connect to it right out the gate. But what I'm doing is for whenever we do our push key, right? Like my baby's talking to me. Pardon. whenever we do our push key, we issue a command. Here, I'm gonna bring my dog over. Yeah, she's gonna help explain this. So essentially, when we implement push key, or whenever we like tell the bot master to push its AES key over to a bot, the AES key is RSA encrypted. And we want to do this for secure transmission so that nobody else intercepts it. Now the bot is spun up with a public key. Is that right? Or is it private? No, it's private key because yeah, the bot master has the public key. So the AES key gets signed with RSA public, and then all the bots have the private key so they can decrypt it, right? So you only really need that for the exchange of the AES key, because after that, you can do communications by encrypting all of your text using AES. And the reason you have to do this is because the space on RSA is rather limited. Now, you might actually been able to finagle a way to shove large amounts of data into that small space, but at the end of the day, you're effectively limited to like 50 something characters for RSA. So it ends up working out for submitting like a very small, like 2-letter command followed by like base 64 encoded AES key. But that was a good explanation, Grace. Thank you. So, in the very beginning, because the bot doesn't have a AES key yet, it does have a private key, or yeah, private key. So it can go through the process of actually decrypting a signed message. And once you do that, you technically wouldn't have to do it after that, because everything would be done over AES. So the way we're currently setting up the network is kind of cumbersome. So like that was what I want the focus of today to be about. The functionality's there, but it is a bit of legwork, and we can do this better, right? Of course we can. So here's how the setup works at the moment. We have to send a command to the bot master first. So at the moment, add neighbor actually does 0 connection. This simply adds an entry into a dictionary to let us know that we have this neighbor. It's kind of like a pre-instantiation. So at the very beginning, you tell the bot master what nodes it's connected to, right? Now, in order to get the other nodes wired up, you would also send similar commands to them. But this is going to change soon because we're now seeking to do communication over encrypted methods for every step, if possible, after the initialization. So currently, or at least previous to this change, we would add neighbor to, like for instance, in a 2-node setup, we would add the neighbor to the bot master, and then we would add the bot master to the neighbor. Now they know about each other's presence, but they don't know each other's virtual address yet. So the whole reason that we have to do this is to tell each node to ask the other node what its virtual address is. They effectively update their dictionary with this virtual address. Then the last step is that they have to become aware of their neighbors. In this case, the neighbors are each other. And so when we actually end up reporting back, because we're eliminating ourselves out of the list of neighbors, the because we're eliminating ourselves out of the list of neighbors, when each node asks each other for the list of neighbors, it's going to return none in this case. So in a bigger network, of course, if you have like more neighbors, this would return a list of neighbors, and you'd be able to update your own local dictionaries as to who your neighbors are. This way you can do the effective Sandberg swap calculation in order to try and change your own virtual address with someone else. So all of that functionality is now going to be wrapped in this AES encryption that we're doing. And in doing, all of this stuff, going through what we have working and adding the code back in, I want to look for opportunities to refactor things a little bit. Hold on a sec. Hey. Changed out shares, and it seems like this is going to be a little bit better on my back. Yeah, my dog's starting to get comfy. I gotta eat dinner here in a little bit, but I want to get these thoughts out before I really forget and see what I could actually do in a short time frame. So the first two steps here for each node, we could actually wrap these two steps together somehow by at the time of adding the neighbor. In addition to that, we could also issue a connection request to get the virtual address of localhost. And so effectively, we'd be able to wrap these two into one step. Hi. Who's watching right now? Let me know your names. So yeah, we should be able to wrap add neighbor and get virtual address into one step. We actually have the functionality for both of these built already. So it should just be a matter of me adding a few lines to the end of the add neighbors phase. And then, so the reason that we want to wait to do get list of neighbors, I feel like, and I could be wrong here. Actually, I know I'm wrong because we'd actually wrap this into the process as well. And one of the caveats of this is that in order to maintain like current knowledge of the network, in order to properly, implement the Sandberg swap such that, nothing gets out of sync, every node is going to have to regularly do updates on its list of neighbors, just in case because if a neighbor adds a new neighbor and the other neighbor doesn't know about it, like every time you add a neighbor, you're gonna have to like broadcast to your own neighbors. I think that makes sense. Probably not doing all of that tonight, but right now, I feel like I can do this part in a couple steps, assuming that my dog lets me. Well, it is getting a little warm in here. Let me turn the fan on. Or up. Okay, so last thing I was saying was when we do the initial add neighbor, we can actually take this value and this value, call get virtual address at the same time. So for instance, we do add neighbor down here, right? But so there's two functions here for vadder. One is intended to return the vadder to the caller. The other is intended to do it this way. So check this out. All right, so here's get vadder from, right? So when we actually call add neighbor, at the same time, call this. That way, we actually don't need to do this part. Now, we wouldn't be able, now, we're not going to be able to do this at the moment until we properly implement the encrypted request handling, because the bot master can at the moment receive plain text requests, which is fine. But we're going to have to update handle neighbor or handle add neighbor in such a way that, hey, I'm right here. I'm right here. We're going to have to update add neighbor so that the request is encrypted first. Fucking type right now. There we go. So we're going to have to push key first before this will work. So let's try it out. All right, so now they've got key exchange, so they should be able to encrypted, communications with each other. All right, so we actually managed to, well, yeah, of course, because Oh, yeah. Also, we're going to have to add a function to the bot master to do the proper neighbor adding. The whole reason for that is bots are now rejecting requests that are not encrypted outside of the pull key request. Hi. Very hard for me to do anything while I'm petting my dog, or at least in the moment, because of which side of my body she's on. My right hand only has so much that it can do on its own. I don't have very much luck doing one hand outside of left hand. All right, so we're gonna have to add a function to the bot master and do something very similar to what pushkey and a lot of the other ones do. So get vadder, for instance. We can use this as a model. Yeah, this is also going to have to be updated. Actually, we'll call this send neighbor. No, see, it's not going to be like that. That's just for a moment. I'm gonna coax my dog for calm her down for a little bit. I'll be right back. Sorry about this, y'all.
I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. When I got my coffee, I'm the motherfucking top B. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking zombie. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking zombie. I need my motherfucking zombie. I need my motherfucking coffee. I need my motherfucking coffee. I need my motherfucking coffee. I need my motherfucking.
Let's see, where did I leave off? All right. They gave me a chance to put some clothes in the dryer, so that's fine. No, but see, add neighbor doesn't actually connect to anything, so this isn't quite what we want to do. No, it's not going to be writer. No, that we have to. There we go. Thanks, Copilot. Okay. Okay, let's see if this works. Let's see if this much works, right? So we're going to go ahead and push key, right? That way it's all set up. And actually, in the process of pushing the key, we should also be able to do like the add neighbor stuff as well, because we're already connecting to the bot, right? So like, why not go ahead and just exchange that information and get everything updated? One thing that we're also going to have to do, especially in the extension of the network, is we're going to have to like, in the same way we're kind of like telling the bot master to instruct individual nodes to do things, we're also going to have to be able to get the bot master to tell bots to tell other bots to do things. So effectively, when the bots are communicating with each other, you know, like we should be able to like start from the bot master. And let's say you have like 5 nodes connected to it, and then you have so many nodes connected to each one, like five to each layer, right? And you're several layers down, and you got to get a message out to a new node that you just added at the very end of the chain, and you have no direct access to it because you're the bot master, but you only have immediate control over 5 bots. But if everything gets constructed correctly, we wouldn't have to directly connect with the new node in order to get it updated. So is at the moment we're kind of like telling the nodes themselves to add these new nodes, but what if a node wants to add itself to the network, right? Like what if a node spins up and we issue a connect request or something, right? Like, let's imagine what that would be like. New node comes up, but it doesn't have an AES key. So one thing that it might be able to do to authenticate itself to the network is be able to like properly receive and decrypt a secret message and then be able to send that back and then have that verified. And upon establishing this authentication, and actually we should do this before pushkey, you know, with the bot master and its own bots, because we don't want to just hand the even a signed key. You know, we don't want to just hand that over, because you know one of the things that we're going to have to deal with in the future is the fact that anybody can look and see what the public key is on the bot if it's running. Like we have no ability, although we could, you know, actually obfuscate this in the code. But like making a keyloader kind of. So okay, so now that we have sent the key over, we're going to send an add neighbor. Receive send add neighbor. Is that not the right name of the command? Oh, oops. Down here. Oh, whoops. Okay, so we actually have to have four parts to this. It's actually got to be like localhost port and then localhost port, right? So in order to implement that, of course, it can't decrypt the command at first because we have not pushed the key. And we have successfully encrypted a request to send add neighbor, and the bot has added the neighbor. Now with the bot master, all we have to do is that, and we've added our neighbor. But like I was saying earlier, um, one of the ways that we can smooth this out, because after we add the neighbor, we're also going to have to ask each bot for virtual address information. We got a few people watching. Nobody talking though. Hope y'all having a good night. Y'all any questions about what we're doing here? Or we are working on the Redking Hivemind. This is a very simple botnet infrastructure. Well, maybe it's simple, maybe it's not, but it's currently less than 1,000 lines of code. A lot of this is comments. This is all self plus Copilot written. I should make it clear in the documentation that Copilot definitely played a part in this. A lot of times when I'm self-writing code, I work with Copilot. If there's a way to plug in something different, I'm interested, but it's not bad. As long as you have a good internet connection, it plays nice. So back when we're adding neighbor, actually I realized too that at the moment, the way that we're doing this, we close the connection with the writer at the end of this command, I believe. Oh no, we're not. Okay, so that means that we can actually do another write at the end of that. Now they handle the send add neighbor. Now we can actually reuse the write here, or the writer here rather. All right, so we got to update get v adder from. We're gonna have to update v adder now. And so this should encrypt the virtual address when we send it back. So even by default, if I were to ask the bot master, it returns a, oh, oh no, we should be actually returning something encrypted. Oh, at the moment, no, we have to update that function. Right. So this actually encodes the virtual address using base64 first. What do you mean it's not accessed? Oh, oops. Let's try that again. Now we get a very long string because it's actually encrypted. So now, get vAddr from, when we send vAddr over, and that's an encrypted request, it should do this. All that should play okay. And this should actually do this at the same time. So let's try it. Oh, right. Yeah, we have to push key first. Invalid hexadecimal floating point stream. Oh, yeah. Wait. Okay, we got the... Okay, it needs to be... Hmm. What if we don't base 64 encode it? My only worry about the whole reason I wanted to do that to begin with is oh, we need to decode it. Wait. Okay, okay, we're doing good so far. Okay, there we go. Okay, we have successfully encrypted the virtual address request as well as the response. So now, of course, asking for either one of them. Oh yeah, it won't even, the second one won't even respond because my request is not signed or AES encrypted. But the bot master can ask, um, so we can do get v adder from. So we should actually write the response out here. Instead of just saving it up here. Um, okay, yeah. So instead of just writing that down here, all right. So the bot master is getting the encrypted response, decoding the base 64 to get the virtual address, which is as you can see, the virtual address over here. So this is a step forward for making all of the interactions, totally secure, right? Like nobody knows what the encryption key is at the beginning when the bots are run. The bot master generates this. I'm curious what Burnett has available to it. Like, I guess we don't have to do any maybe I can get a little more info. From it's got like no help. Oh well, it was worth a try. So I'm thinking, reading about this. So one of the things I'm thinking about right now is variable corruption. What happens to a bot if after the key is initialized, for any reason, perhaps someone's able to intercept the process and they accidentally wipe the key out? Is there a way to recover interactions with the bot? And the answer is yes, because we can simply push the key again. So, problem solved. Now, it would be actually kind of useful to have like a third bot that is like a bot control, like the bot master controller. I'm not going to do that right now, but just thinking out loud, because at the moment while I'm testing, everything's running localhost, right? But one of the things that we might want to do is extend this so that, like, for instance, the botmaster is running on a remote host and you have a botmaster controller on your local host that you use to drive the botmaster, right? So like botmaster driver. Or you could maybe we can get away with running the botmaster locally. The reason I was thinking about that is just as a security feature. Ultimately, anyone, like, we would want to hide control or knowledge of control of the master node if possible. We would also want to be able to, like, for instance, given a, properly encrypted request and everything, actually. Yeah. Ultimately, the controller we don't actually want included in the neighbor map, right? Like when we're doing netcat, the local host, like, we're not adding ourselves as a neighbor, we're adding running processes, right? Like based on host port. But one of the things that we can do like, the whole reason that the bot master is able to receive plain requests is that it's acting as a controller for the network. So one thing that we could do is, in the process of pushing keys, do not attach the bot master to the network, and instead keep the bot master separate and use it simply to drive commands to, like, initial nodes. Because if we do this right, then after the initial part of the network is constructed, and every time we add a node and attach it, if we do it right, when the bot master connects to a node to propagate commands through the network, we can issue one command to one node in a network of 10,000 nodes, and everything should play nicely together. I'm gonna stop rambling. I think this is all I'm doing for right now. I want to thank y'all for joining, but focus is limited, so I take it while I can get it. Till next time, everyone. Peace.